Pawan Kishore from Indus Ecowater. Today's agenda is we will discuss more about STP, how to select STP. So more into STPs, how to select of STP. That is the main agenda is our this one today's topic. So let me introduce Mr. Suresh Kumar, our founder and chairman. He's technically sound and is now briefing about and taking all classes. Thank you very much, sir. Over to.
Thank you, Kishore. The agenda for the day is how to select the right sewage treatment plant, right? That means anybody who has attended here is in a position to take a decision about sewage treatment plant, or in a position to influence, advise others about what is right about sewage treatment and what is not so right, right? Just for the record, why we need to have this discussion today here is 70 to 80% of STPs in India are non-functional. They are not operational. They are not in use for whatever reasons. We'll go very deep into understanding what are the reasons why they are not functioning, how we can advise our clients to set up STPs that operate properly. And this is not just for a residential use or commercial use. It is across all spectrums, right from municipal STPs to the smallest possible septic tank. Most STPs are dysfunctional. Okay, so we are going to deep dive into that discussion as to why it is like that and what we can do to solve this problem, right? And please hold all your questions. We are going to have 15 to 20 minutes at the end of this discussion. This conversation is going to last something like 1 hour, this session, and out of which 40 minutes will be my presentation. Last 20 minutes, 15 to 20 minutes will be your questions and my answers. And even if it gets extended a little bit more, another 5-10 minutes, there is no problem. We'll answer all your queries to your satisfaction. All right. Okay. Now a brief introduction about myself. Am I qualified to take this session? Do I have that kind of experience? I'm in water and wastewater treatment business for the last 25 years. My water career started in 2020. I've set up more than 1,000 sewage treatment plants, starting from a very small 2,000 liters per day right up to 4.5 million liters per day for municipal application. Right. This has been my 1,000+ years experience, and I am well exposed. I have used hands-on all sewage treatment technologies like extended aeration, electrocoagulation, MBBR, SBR, MBR, you name it. I have used the technology. Okay. So I'm uniquely experienced and qualified to share this session with you. If we are ready, we'll deep dive, right? Yeah. Let me start presenting my screen. Now the agenda is how to select the right sewage treatment plant. And the fact that we are talking about this means we are somebody who is going to influence our use. We are a user of STP, we are a seller of STP, we are a manufacturer of STP. Somewhere we are connected to sewage treatment. All right. Now, why should we select? Why should we select the right kind of sewage treatment plant? That question is, why should we select? As Kishore already explained, here is a brief agenda of our discussion for the day. First, we are going to look at a technology overview. What are the various technologies? Then, what are the factors that influence how to select the right STP? And then various technologies, their advantages, disadvantages, and then common selection mistakes, what mistakes people do while selecting a sewage treatment plant, and our advice along with a few case studies of failure, so that we all learn from their mistakes. All right. Why we need to get into this topic is 70% of STPs are not in use for various reasons. And these STPs include municipal STPs, residential, commercial, all types of STPs. Most of them are not in use. It's not because government is not asking them to be used. When municipality or pollution control board is asking us to set up an STP, it is with the clear intention that you set up an STP and you run it. It's not that you just set up and forget. It is, the intent is set up and operate. Okay, use it. But why they are dysfunctional is many a times there are multiple reasons. One of the main reason is cost. A second reason is people want to run it, but they are not able to run it. Right? We're going to discuss in detail what are the reasons and what we can do about it. As things stand, most STPs today are installed only for compliance purpose, not for operational purpose. These are fact of the day, including municipal STPs. Government is calling tenders. We are going participating, but most municipal STPs are not operating the way they are supposed to do. And small STPs, nobody really bothers. You just set it up, and at the end of the time, you forget. The only reason why STPs are not functional is the people who are supposed to take a decision are making wrong choices. These wrong choices are sometimes intentional and sometimes unintentional due to lack of knowledge. Why I am saying intentional? Let us say a government is taking a decision to set up a advanced SBR technology in a rural environment on a taluka headquarter kind of place. They know it is not possible to get experienced technicians to go and work there, but still they go ahead with the technology. And because experienced SCADA operators or STP operators are not available in those remote places, they are not functional. What should government do, or what should the decision maker do? He should use a technology that is suitable for the location, that does not require much of manpower, qualified manpower. Right? It's like you are taking a Mercedes Benz onto a village where there are no roads. In 1 month, 2 months, your suspensions are gone, and you just confine it to your shed. And second thing is, like most apartment owners or commercial builders, for them, it is mostly lack of awareness, lack of knowledge as to what is suitable for their specific requirement. Now, we are going to deep dive into this. What are the problems? Why STPs are not functional? Number one, operator-related problems. That means either operators are not available, or operators don't have the skill, or operators' cost is extremely high beyond the budget for the project. A second is equipment-related problems, where you have very high-tech equipment. The equipment is non-functional, either due to operator's mistake or operation and maintenance problem, or a replacement is not available. Let us say a DO sensor is there. A DO sensor needs certain level of maintenance. If that maintenance is not there, it goes off in a matter of 6 months. After that, replacing is expensive affair. Availability itself is again a question mark. Right. And then there are some site-related problems. What are the site-related problems? Okay, you had set up an STP at wrong invert level. You had set up STP in subcellar where there is no ventilation, where the STP should have been set up outside where plenty of air is available. Right. And cost-related problems. The cost of running an STP is so high that you have no option but to shut it down. And finally, user-related problems. Users do not want to pay money. Users are not interested in running the STP because it is going to cost them some money. They had set up because government has pressurized them, Pollution Control Board or Water Supply Board has instructed them to set up. They have set up, but they don't intend. So these are some of the reasons why STPs are not functional, not in use. But most of the time, the buyer is not aware of these problems before buying an STP. I'm repeating again, the buyer or the decision maker is not aware of these potential problems while taking a decision about buying the STP. Sounds very strange, right? Many a times we think people take a learned decision, but that's not the case. This webinar today is our way of contributing to creating awareness. This webinar recording will be put in YouTube also, right? So that people, whoever wants to know, come, understand, and take a learned decision. All right. There are multiple technologies available for sewage treatment. Let us look at technologies, multiple technologies. The simplest, most cheapest technology is septic tank. We all know, if we are from a rural background, we all know what is a septic tank. In villages, in good old days, when I was relatively young, in my schooling days, we just used to have septic tank. It just had two pits where solids are retained in the pit, while liquid goes into the ground, right? Typically, the kitchen wastewater was never sent into the septic tanks. It was primarily the fecal matter and the bathroom wastewater that is coming in that was going into the septic tank. And we have something called extended aeration, the earliest version of sewage treatment. Incidentally, sewage treatment was started in London, right, in the 16th, 17th century, and it came into India in 19th or end of 1930 or 1950. That is a kind of time. Okay, extended aeration is one of the oldest known technologies for sewage treatment. Jokasu is a technology from Japan, very popular in Japan, and electrocoagulation started in 1934, invented in 1934 in Germany, again stands out as a unique technology. Most of the time, all other technologies except for electrocoagulation depend on bacteria to eat what we want to take out. Let us just look at for 1 minute. What is sewage treatment? What is sewage? Sewage is a wastewater. Sewage is the water that comes from our usage. It was water primarily. We used it, so it has become wastewater. Let us say I used water for washing my clothes. So what is there in clothes that is getting into this water to make it sewage is nothing but soap and maybe a small quantity of oil and grease and dust. It is the soap film that is carrying this into the water. Primarily it is soap. Now, same logic if I extend, I used a coffee cup. I washed the cup with water and maybe with some small quantity of soap. Now, what is this water is now becoming wastewater. What is there in that? Traces of coffee, that means traces of milk, fat, sugar, and coffee powder. Along with the detergent that I used, this is going into water. Sewage is 99.95% water. Please remember 99.95% water and 0.05% these impurities. What are these impurities? These impurities can be the soap that we are talking about, a chemical, and the food particle like the coffee beans powder, sugar, milk powder, fat, right? Or the dust that came from our clothes, or the fecal matter that we excreted in our toilet. So all these things are the impurities in sewage. So the purpose of sewage treatment is remove this 0.05% impurity so that your water becomes 100% water. Previously, it is 99.95% water and 0.05% impurity. The whole exercise is removing 0.05% impurity. Sounds very simple, but equally challenging. Okay, now there are multiple technologies, but all the technologies use principles of nature. What does it mean? Principles of nature means you leave a lump of sugar on kitchen platform or anywhere for that matter. First, flies will come. After a while, ants will come. And they'll come eat it. How do ants and flies know that there is some food for them? Their sensory perception is extremely high. Likewise, wherever there is food, food means energy. Every living thing requires food. Okay, so the primary purpose of every living thing is to survive. They require food to survive. Wherever the food is there, some kind of living organism, be it bacteria, virus, whatever, will come and eat it. So wherever food is there, bacteria comes automatically. We don't have to do anything extraordinary to bring bacteria, and that bacteria will come and eat. But please understand, bacteria is a unicellular organism. That means there is only one cell. It's very sensitive to temperature. 1 degree increase in temperature can kill bacteria. 1 degree decrease in temperature can kill bacteria. Right? It flows along with water because it is not even visible for you to our naked eye. Unless we put a microscope and see, bacteria is not visible. Right? So it just goes along with water. We don't have to do anything extraordinary to grow bacteria. It grows. But we can create favorable conditions where bacteria grows much faster. And sewage treatment is not something that one has to invent. Sewage treatment is a natural process. As long as human beings have been in existence or nature has been in existence, this kind of treatment is happening by nature. You know, cow dung, animal dead bodies. They die, they lie on the field. Some vultures will come, eat it. The rest of it goes into, when it rains, it goes into the water. In the water, bacteria will proliferate, eat what is visible physically, and what is dissolved in water also is consumed by the bacteria. So simply speaking, sewage treatment using any of these technologies that we are talking about here, septic tank, extended aeration, Jokasu, RBC, moving bed bioreactor, or any process, is simply SBR or MBR, simply uses bacteria to eat what we want to take out from water. Only electrocoagulation is a different technology. It just uses electricity to destroy bacteria or destroy the organic content present in water. Right? There could be many more technologies, like people use phytoremediation, soil biotechnology, various things. You name it. It's nothing but you're creating favorable condition for bacteria to grow. So once you understand, it's as simple as that. Life becomes a lot more easier. Okay, all technologies are same in the sense that they use bacteria. Now let us understand in detail which technology does what, how. Let us begin with the simplest and the oldest, the septic tank, right? Septic tank is good. Septic tank, a lot of people think it is not sewage treatment, but septic tank is also sewage treatment. It reduces BOD by about 70%. Now, one simple example of septic tank, if I can give, Indian Railways set up these bio toilets. They have taken it as a mission. Now, if you walk into any railway station, there is no smell. 10 years ago, railway stations used to be stinking. Today, there is no smell. All the stations are clean, spick and span. This has happened with bio toilet. Bio toilet is nothing but a septic tank. What they have done is they have introduced a bacteria. They call it inoculum, some type of bacteria, which consumes this organic content much faster and grows faster, and it is resilient. Okay, they have created storage tanks for giving time for this bacteria to eat the organic content, some retention time on the railway coach itself. Just after the toilet, there is a small compartment of about 300-500 liters. So any water that we are giving in will be there for at least 10 minutes to 1 hour. During this time, bacteria would have eaten what we want to take out. So that what is left is only water, right? So this septic tank can and will reduce BOD up to 70%. Sometimes it is good enough. We are seeing from the railways example that 70% reduction is just sufficient for the need. Okay, but it also generates a mild foul smell, a smell of rotten eggs. Okay, if you are in a closed space, this smell will be nauseating. If you are in an open space, this smell doesn't matter. Like railways, they are open, so the smell is almost invisible. You don't feel it at all. All right. What is good about this septic tank? There is ultra low cost. There's just almost no cost. You've set up and there's no cost. Bacteria is growing on its own. You don't have to do anything from positively from our side to keep it running. It just runs on its own, right? So the sludge disposal is the only cost. That too, if maybe once in a year or once in 2 years, we have to dispose of the sludge using a tanker. For that also, government has set up fecal sewage sludge treatment plants at municipal level in various cities. And for places like Kerala, where underground drainage is not possible because of the hilly terrain, septic tank is the only option, de facto option. So Kerala thrives on septic tanks. Kerala has multiple septic tanks. Every house probably has a septic tank. All right. Now, it is also suitable for farmhouses where there is no need to have underground drainage, but you want to avoid the foul smell. You don't want flies and ants to come and create nuisance. For such ambience, this is good. But on the negative side, this cannot meet discharge standards. That means you are not permitted to throw the treated water from your septic tank into municipal drains. It is not permitted. Okay, so this technology has limitations, but the limitations are it is good only up to very small capacity. When I'm saying small, probably 2 KL is ideal, but up to 10 KL is okay. manageable. I have also seen some colleges, universities having these kind of plants, but not advisable. All right. Now, let's move to the next technology. The next technology we are talking about is Jokasu. Jokasu has its origin in Japan. Japan is similar to India, has extremely high population density, and underground drainage network was very scant, was like what India is today. Japan was in early 80s. So they developed a sewage treatment system for each house. Every house must have a sewage treatment plant, right? So in a small country like Japan, there are 80 lakhs to 1 crore STPs. Every house has a STP. It's like a water filter. You only throw out treated water from the Jokasu, right? Now this is recommended up to 50 KL. What does it do? The best part is it reduces your BOD right up to 95%. And this is factory made, ready to install, easy to install. Installation happens in 1 or 2 days time. That's one big advantage. There is no need for extensive, elaborate civil works, and has very low capital cost. That means civil works are avoided. There is no operator required, and low power cost. Okay. And this is ideal for residential applications like villas, apartments, factories, schools, colleges, right? Wherever the requirement is small and skilled operators are not required or not available. And it has a slightly higher capital cost as compared to septic tank. It is more expensive than septic tank, does require power. Septic tank does not require any power connection also, whereas this requires power and has about 20-30% of power consumption as compared to SBR MBBR, but gives you better quality water compared to SBR MBBR. Let's move to the next technology. MBBR, moving bed bioreactor. Moving bed bioreactor has become popular in early 2000s, where sewage treatment has really started taking place in India. Mostly it started with industrial wastewater treatment, where you have high strength wastewater like dairy industry, like pharmaceutical industry, like textile industry, where BOD COD reduction is essential. It started from there and came into domestic sewage treatment. It does reduce BOD CODs by about 70%. COD reduction is not very effective here, but BOD reduction is very effective. All right. Now, what is BOD? What is COD? We have multiple presentations on each of these technology. You can go to our YouTube channel, watch. If let us say you want to know more about MBBR, there is a presentation or a webinar recording like this, exclusively on MBBR, exclusively on SBR, exclusively on Jokasu. We have all these things. If any of you are not able to locate those links, please get in touch with our team. We will help you. We will share the link for you. All right. Now, where is MBBR required? MBBR is an advanced technology as compared to extended aeration. Like we discussed in the beginning, extended aeration is the first proper sewage treatment technology. It required a lot of space, large tract of land was required. The tanks were very shallow. From there, if development is MBBR. MBBR is ideal with capacities from 50 KL to 500 KL. And what is required for below 50 KL? If it is very small, go for septic tank. If it is up to 50 KL, but you need better quality water, go for Jokasu. All right. Now, this has low capex. When I'm saying low, it's always relative. It does not mean zero. And compared to other technologies like SBR or MBR, this has low operating cost and does not require highly skilled operators. It requires operators, no doubt, but it requires operators with minimal skills. Those skills can be imparted in a matter of 3-4 days time, right? When you use this along with ultrafiltration, it gives you extremely high quality treated water, which you can use for toilet flushing, which you can use for cooling tower, HVAC applications, etc. But on the negative side, this has large civil works. It has a huge operating cost. It consumes power because this process is dependent on air. So you have to pump large quantity of air into the process tanks. So many a times this causes some noise also. Noise, vibrations, and operators are also required 24/7. These are some of the disadvantages of MBBR, but where it is suitable, we'll get into that in a moment's time, as we are focusing on technologies right now. Let us move to the next technology. Sequencing or sequential batch reactor, SBR. SBR is something, as the name specifies, batch. MBBR is a continuous process. This is a batch process. Okay, batch process has some built-in advantages as to you don't have to run the STP 24 hours a day. Right? You can afford to run the STP only 1 shift, 2 shifts, 3 shifts based on the load. Okay. So based on your variable flows, so this can be used or ideal for flows where there are we are seeing a lot of static and disturbance. I request some of the members who are speaking
Sir,
to mute
actually,
themselves.
yeah. Few people are just joining, so just please unmute. You have to mute, sir. You have to mute.
You want me to mute them or unmute
Yes.
them?
Mute them, sir.
Okay.
At the question hours, you can unmute them.
Okay. Just give me a second, please.
मनोज झुम केली का त्या पवन किशोरची त्यासाठी तुला बोललो होतो तेवढं मला वाटतं तुला माहित नसेल.
I'll just stop. Come here. Give me a second, please.
Hi all, thank you for joining. Now the session is in between. We have started around 11:15. So the question hours will be around 12 o'clock. We'll extend our time up to 12:15. But the question hours will be there. Please be ready. आप जो भी questions पूछ सकते हो आप openly पूछ सकते हो question hours में. अभी sir mute करेंगे. Now sir will be taking care. Yeah.
We will be muting everybody so that there's no disturbance to others. All right. Just trying to locate the controls for muting everybody. Okay, let me go back to my presentation. Right now the static noise has stopped. Let me start presenting my screen again.
Yes. Yeah.
All right, please confirm if my screen is visible properly to all of you. Right, going back to the topic, let us understand a little deeper as to what is SBR. SBR is an abbreviation for sequential batch reactor. When we are saying sequential batch reactor, sequence is one after the other. Batch is, that means you can process the water in batches. All other treatment technologies are continuous processes like MBBR, Jokasu, or septic tank. You just switch on day one, it just keeps running. You cannot switch off the system in between. Whereas SBR is something based on the availability of sewage, you can switch on the system or switch off the system. Where it will be used, we'll go into that little later after we understand each of these technologies in little more detail. All right. And this is ideal for variable loads. There are some places like shopping malls, hotels, star hotels, hospitals, and even municipalities where we don't know how much water we are going to generate. On a shopping mall, if you see, weekends we have full capacity, 100% capacity. Rest of the days, Monday probably 20-30% of capacity. So you can't set up an MBBR in a shopping mall and expect it to run properly. Because one day you have fed the bacteria extremely high food, next day there is no food. This kind of a situation, biological process cannot survive. So SBR process as a process is more suitable for hotels, shopping malls or commercial complexes, IT buildings, hospitals, or even large capacity municipal STPs. Even large capacity municipal STPs have variable loads because their load is dependent not only on people, it is dependent on commercial establishments. So wherever the commercial establishment loads are fluctuating, the municipal STP loads are also fluctuating. So this is ideal for such variable load situations. Okay, what are the disadvantages? It has high capital cost. The civil construction cost is high. The process is totally automated. That means the technology level is high. Incidentally, when the technology is high, the capital cost is also high. And to run this high technology equipment, your operator requirement skill is also high. You need highly skilled operators to keep this plant functional. Along with UF, this gives you extremely high quality water, which you can reuse. When I'm saying extremely high quality, MBBR and SBR give you similar quality of water. In terms of water quality, there is not much of difference. MBBR is more suitable for constant loads, where the load is not fluctuating beyond 5-10% every day. And SBR is more suitable for fluctuating loads. So why not put a MBBR in a hotel or hospital? One day you are given full wastewater, next day there is 50% wastewater. The third day again 20% wastewater. MBBR will fail if we are selecting it for hotels, malls, hospitals, municipalities, etc. Likewise, SBR will be okay if you set it up in a residential setup, but the problem is your capital cost is going to be high. Your operating cost is going to be high. In a residential setup, it may not be possible to sustain such high capital cost. All right. And it also has large civil works, big size blowers, which make noise, vibrations, and the operating cost is high, and you require skilled operators. All right. Now let's understand one more technology that is a fashion today. A lot of people ask me, should I go for MBR? Right? MBR is an abbreviation for membrane bioreactor. It is simply an MBBR plant. In the last stage, we are inserting a membrane into the sewage so that it extracts quality water. It's like a filtration system. It's nothing but a physical filtration system. Okay. Now, this is nothing but MBBR plus a submerged ultrafiltration membrane. A lot of people think this is a fashion. This gives me high quality water. But here again, the efficiency of this system is dependent on the efficiency of the biological process. If your biological process, which is part A of the system, is failing, your part B membrane also will fail. If you don't treat your sewage properly in the first aeration tank, if you don't remove oil and grease, then your MBR membrane is going to foul and choke. Okay, so the misnomer that this gives high quality water is somewhat unfounded. It does give high quality water when the system is functioning properly. The same result can be achieved when you use MBBR plus an external ultrafiltration membrane. At least when you are using an external ultrafiltration membrane, this ultrafiltration membrane is not dependent on biological process. On any given day, if your biological process failed, you can simply switch off the ultrafiltration system. In MBR, that flexibility is not there. But MBR is used in certain applications for various commercial reasons. Most of the time, I want to sell a high cost equipment to a client who has got budget, so I offer them MBR. Beyond this, I did not see much logic in going for MBR. Sometimes some customers want to showcase this as a high-tech equipment, like you are selling a very expensive real estate property, each apartment costing 20 crores, 30 crores. Then you would like to say, no, I have used MBR. Right.
Information.
And one of the biggest costs is ultra high membrane cost, membrane replacement cost. Here the membrane would last about 5 to 7 years, but at the end of 5 to 7 years, the cost is extremely high. Okay, now we have understood basically the most popular technologies, how they work, where they are suitable, where they are not so suitable. But please understand, there is no perfect technology. Perfect technology does not exist. We keep improving as time progresses. Each technology comes with its own good and bad. So we have to select what is suitable for my requirement.
Dinto webinar follow avutuna dinto ida naaku tetrangi pettudaniki sarpadu idi ikkade pettosta
Somshekhar garu, is this Somshekhar garu?
Yeah, there is a lot of disturbance.
Somshekhar garu, please mute yourself.
Okay, sir.
Yeah, thank you.
Sorry.
Yeah. Thank you. So, okay. So you have to select the technology based on your specific requirement. If I am setting up an STP in a shopping mall, if I use MBBR, it is bound to fail. So as a buyer or as a salesperson, if I am going to sell an STP to a buyer in a shopping mall, somebody who is constructing a shopping mall, I have to tell my client, these are the advantages, these are the disadvantages, and this is ideal for you. This is the ideal technology. SBR is the ideal technology. In the same way, if I'm going to an apartment complex or a residential builder, if I offer them SBR, it comes with high cost. If I offer them MBR, it comes with high cost. Right? I have seen some very spectacular. Okay, anyway, that part we'll discuss in case studies towards the last chapter of the presentation, where STPs have failed. All right. Now, what we have understood now is each technology is good, but it comes with its own good and bad. There are some positives, there are some negatives for each technology. You have to choose the technology that is right for your site. When I am saying this, a technology that works in Chennai will not work in Delhi. Please understand this. An MBBR STP working in Chennai may not work as effectively in Delhi. How is this? Okay, understand. It depends on bacteria. Bacteria grows at certain temperature. If the temperature is low, or the lower it goes, if it goes below 10 degrees, bacteria growth is non-existent. Bacteria does not grow at all. If the temperature is around 15 degrees, your aeration tank size should be double as compared to Chennai. In a place like Delhi and most part of North India, the temperatures go extremely low, like Punjab, Haryana, Himachal, Jammu and Kashmir. There are sub-zero temperatures. At those temperatures, sewage treatment simply is not possible. Okay. To a small extent, to a very small extent, septic tank might work there. To a small extent. Beyond that, most of the technologies do not work. In such a place, if we are serious about treating sewage, we may have no option but to go for electrocoagulation. Okay, so based on your location, based on your project, right? For example, if we are talking about RBC, I have seen some very spectacular failures of RBC in Hyderabad. RBC is some technology which is popular in Indonesia back in 70s. So some vendors brought it to India, explaining clients that this is an imported technology, is going to do wonders, etc. If it is in open air, where there is plenty of aeration, RBC can work at least partially. But you take the same thing underground, put it in -2 subcellar or basement 2, where there is no wind or ventilation at all. Because in the absence of any air, bacteria cannot grow. So the technology has failed. This is what happened in multiple prestigious projects. One vendor particularly has sold this technology as a, what should I say, as something like a God's gift to big builders, and big builders have big spectacular STP failures. Okay, so you have to choose what is right for you, depending on number one, what is the reason why you are setting up the STP, right? Let us begin with why you are setting up the STP. This is the reason number one, or this is the case where we need to understand why we are setting up the STP. Based on that, we need to use the technology. Let us say I don't have to set it up for compliance reasons. I have a farmhouse. Compliance is not my problem. Then I don't have to go for highly advanced technology. Something like SBR, something like septic tank, or worst case, Jocasi is good enough for me. If I have to meet pollution control board norms, right, regulatory norms, the norms have to be understood very clearly. The Kerala norms are the stringent in India. Kerala norms say BOD below 5. Karnataka norms say BOD below 10. Telangana and Andhra norms say BOD below 30. Rest of the country, most of the time, it is BOD below 30. So if I am setting up a MBBR STP in Kerala, many a times it is not sufficient. So first, when we are setting up an STP, we need to understand what are the norms in that local area. The Pollution Control Board discharge norms or reuse norms. Based on that, we have to choose the technology. There, if I have to set up an STP, it should be based on MBBR plus ultrafiltration, or MBR, or SBR plus ultrafiltration. Again, based on the sewage generation pattern. Okay. Now, if I am setting an STP for reuse of treated water, like we are in Bangalore, there is acute shortage of water. I want to reuse water. So I am setting up an STP. Compliance is also one part, but my major motivation is to reuse treated water. Then I need to define where I want to reuse this water. I want to reuse this water only for flushing. I want to use this water for HVAC application, cooling tower. Based on this particular requirement, I need to choose a technology. Here in Hyderabad, recently we take up one project, 100% reuse of water. It's a IT building where coming up in financial district, acute water shortage, 100% water may have to be bought either from municipality or from any other tanker source. No groundwater available. So they would like to reuse as much water as possible. So what we had recommended to them, go for an SBR because it is an IT building, loads are fluctuating. First condition. Second, go for ultrafiltration. UF treated water goes for flushing, and UF treated water cannot be used for cooling tower. So they wanted to use cooling tower also. So then the water that is left after flushing, that is going for RO, and from RO, the RO product is going into cooling tower. So based on your need, first understand what is your requirement, what is the quality there, and then decide on treatment process or technology. And if you are simply trying to avoid a foul smell, many a times this happens if you are there little away from city. If there could be a university or school or hostel where foul smell is the main problem, or some neighbors are complaining that your water is coming into my field and causing me nuisance. In such cases, maybe a septic tank is good enough. So the primary way of looking at things is understand why you are setting up a STP. Based on that, go for a treatment project, right? When you are going for this treatment project process, understand local PCB norms if you want to discharge. Then consider capital cost. If you want to have something like MBR in a remote place, the government might say, for example, in Kerala, every STP needs to give BOD below 5. So that gives us only two options, either go for MBR or any other technology plus ultrafiltration. So the tendency in most Kerala customers is go for MBR because they think it is very simple. But the reality is MBR is a very complicated process. It requires highest possible level of skill. It requires skilled operators. The membrane replacement cost is extremely high. So because of these reasons, the technology is not sustainable. When the technology is not sustainable, if the operator is not available, your best Mercedes-Benz STP is of no use. You have to just put it in the garage, shut it down, right? So consider availability of manpower, requirement of such high equipment, right? And local availability, ultimately. Okay. Let's again look at the condition. Variable flow versus constant flow. This is the first thing that you should look at. Do I have same flow every day? Do I have variable flow? If I have variable flow, the choice is always SBR. SBR plus can be something else. If I have constant load, it is MBBR, can be plus. If you are there in Kerala, it could be MBBR plus ultrafiltration. If you are running a hospital in Kerala, it is SBR plus ultrafiltration. Or if you have the budget, MBR, right? If you are there in Bangalore, you want to reuse the water, it can be MBR or SBR plus ultrafiltration. If you are there in some area where there is extremely water shortage, there is no water whatsoever, you want to reuse 100% water, Then it is any technology like MBBR or SPR based on your variable load conditions or constant load conditions plus ultrafiltration plus RO. These are all saturated technologies. There is no rocket science in sewage treatment today. Sewage treatment is proven beyond any doubt. So anybody can do a proper job if you take the right kind of precautions. All right. But please understand, a sewage treatment plant is not only built, but it also has to be operated. Right. And when you are setting up a plant, please understand it is going to cost X amount of money to keep it running. An operator, for example, an operator will cost you at today's cost minimum 20,000 rupees per month. Any technology, any proper technology would require 3 operators per day, 3 people working in 3 shifts. That means every month 60,000 rupees. This is only the operator cost, whether your STP is 100 KL, 200 KL, 300 KL. And then 1 HP power will cost you 50,000 rupees per annum. How is that? 1 HP is 0.75 kilowatt. When you run a motor of 1 HP motor or pump of 0.75 kilowatt per hour, 24 hours, it is consuming 18 units of power every day. 18 units multiplied by 30 days in a month is going to give you 540 units. 540 units at 8 rupees per unit is 8 5 is 40, 4,300 rupees per 1 HP per month. This 4,300 in 1 year is multiplied by 12. 48,000 plus again 2,000. It gives you almost 50,000 plus. So please understand this cost. Okay, before taking a decision, you have to keep a budget, not only for buying the STP, but running it also. All right. We covered all this. We are already setting up, we discussed this point. If you are there in a remote area, consider using operator-free technologies where not required. Okay, now we are done with our presentation. We'll come back to your questions. Your questions now, please. Somshekhar garu, please unmute yourself. So any questions, sir, from your side? Somshekhar garu. Sir, you are on mute. You have to unmute, please. So any questions from any of the guests? Seeing almost 16 participants. No questions means you have understood everything. So please.
Any language is okay.
Any language. Hindi, English,
language.
Telugu.
Hindi, English, whatever, convenient language.
And if you're having any problem of unmuting yourself, please put it in the chat.
Hello.
Yeah, please go ahead.
Are you hearing me?
Yeah, you're audible, please.
Yeah. Actually, somewhere there is a requirement of grey water. What is the grey water in wastewater and how to treat the grey water?
Okay, this is a very good question. Grey water means the water that does not have much of organic content. Okay, when I am saying organic content, food is the primary source of organic content. Fecal matter is the secondary source of organic content. In wastewater, if you see, in our sewage, when we say sewage is the water that is coming from our bathroom, from our toilet, from our laundry, from our kitchen, right? So the water that is coming from kitchen and toilet flushing is called black water. This black water has high content of organic and also pathogenic bacteria. Grey water is something that is coming from our laundry, coming from our bathroom, that means showers and hand wash. So wash basins and showers plus laundry. These 3 are giving you grey water. This grey water primarily has a lot of COD, contributed by soap. It does not have much of organic content. Okay, now the next thing, how to treat this gray water? Technically speaking, treating gray water is more difficult compared to treating black water because bacteria cannot eat chemical content. You know, when you use a soap, a chemical called LAB, linear alkyl benzene, will go into water. And every soap also has a small quantity of fat. Basically, all the soap is nothing but fat and LAB. Okay, so it is difficult to remove it using a biological process. So traditionally, some people are using chemical process. You just treat it chemically, aerate it, filter it, and suitable for discharge. If you are using higher level of water quality, you may have to go for partial biological treatment, but it would require more elaborate treatment as compared to black water. Did this answer your question or any?
Yes. Another question is what? When we have started the sewage treatment plant in we can aerated system.
मैडम आप अवेलेबल है मैडम, क्वेश्चंस पूछ सकते हो आप.
Hello.
Sure,
hello.
let them finish. Please go
Are
ahead.
you audible?
Yeah, you are audible. Please go ahead.
That time in aeration system, lot of foam is
coming.
So how to treat this foam to maintain the MLSS?
See, there are two
Because
things.
defoamer is not suitable for MLSS, I think.
No, there is nothing like that. See, foam comes because you have extremely high content of soap, number one. Number two, the ambient temperature is high. Foam comes, more foam comes in summer compared to other seasons. You have to use defoamers like eucalyptus oil, right? If it is possible, treat the water with anaerobic digestion before sending into aerobic digestion. Okay, where the COD contributed by soaps is at least partially reduced, if not fully, at least partially reduced. There are no foolproof methods of foam removal. You can only control by spraying eucalyptus oil on the foam.
Okay.
All right, but it has no impact on the MLSS. Please understand that it only causes the visible nuisance. Like foam comes out, it falls on other people because you are aerating, the foam will start flying in the air. This is a visual nuisance. Otherwise, foam is harmless. You can contain this visual nuisance by putting some shroud or something like that around the aeration tank. Put some plastic baffles or something which prevent foam from coming out of the tank. These are some of the things that you can do. But you have to spray. It is not as if you are dosing. Dosing is different. Put a sprinkler and spray eucalyptus oil on top of your aeration tank. Okay.
Sorry, I missed this one question, Sureshji. This question was asked about eucalyptus oil. What was the background behind it? Because I lost my network in between.
Eucalyptus oil is basically used to control foam. See, some applications, especially like where commercial laundries, they generate a lot of foam. And if your aeration tank is open to air with higher temperature, ambient conditions, like sunlight is coming and directly hitting your sewage, your aeration tank, then the foam content is very, very high. And there is no way to control foam except spraying eucalyptus oil. But if, as a system designer, if I am designing a plant exclusively for laundry wastewater, first I would push it into a anaerobic digester followed by aerobic digester. Anaerobic digester, my COD content is reduced drastically by bacteria that eats off this kind of lab. So eucalyptus oil is primarily for foam control. It's only a physical method of controlling it. There is no chemical reaction in the process.
And it does not affect the...
No, it has no impact on the MLSS or biological process.
And this is commercially available eucalyptus oil you can use?
Yes, commercially available oil.
Okay. What type of dosage or just for my understanding, is it just too much?
There's nothing like a one thing works for every situation. You have to,
Right.
because we don't know what is the kind of, under normal circumstances, domestic sewage will not foam as much. But if it is foaming, that means there is some extremely high content of soap coming in, soap or fat. So depending on your soap or fat content, you have to dose. Typically, dosage is 3 to 5 ppm, not more than that.
Okay.
That means per kl of water, 3 grams to 5 grams. If you are treating 100 kl, 300 grams to 500 grams per day.
Right. Thank you.
Yeah, thanks. Any more questions, please?
No, I have one question that I had in mind when we were hearing you. When it comes to treating sewage and all, of course, the BOD and COD norms are there.
Ji,
BOD, I don't know, can be checked or not, but for COD, this is a concern. The minimum COD you can measure effectively with the current, approved methods of digestion is around 20 ppm. If
Right.
the norm says less than 10 ppm, how do you check such a COD?
Sir, I'm not a chemist. I know the
There is one client. No, there's one client. The norms I'm from Gujarat. There's one client in Gujarat who has, the normal norm in Gujarat is less than 30, BOD and less than 100 COD or something like that.
Ji.
But for one customer in Gujarat, but he's in a certain zone, in industry zone, where the norms for him is stringent. He has to meet less than 30 or less than 50, COD, something like that. Either COD is less than 50 and then BOD is accordingly less than 10 or something like that. Where COD, I know it is very difficult to, how do you check for such COD? You may have reduced it, but how do you check for such a, because how do you explain the PCB saying, okay, we have achieved this, but once you test it, just the testing error can vary the COD by 30, 40 ppm between two different chemists.
Yes.
How do you attend such a situation?
I'm talking from common sense. I'm not a chemist, although I have done COD with the titration, that reflux method, putting it for incubation, etc. I can only say PCB will give you a benefit of doubt, or use some online instrumentation where COD measurement can be done using a sensor without operator. The error can always creep in. There is no foolproof solution for that.
Okay, thank you.
Maybe an online sensor that should solve your problem, or take up with standard vendors like Hatch. You have these sensor manufacturers. Any of them might be able to give you a sensor that has accuracy range of 10 to 20 ppm or 10 to 50 ppm.
Understood.
Just a thought.
Yeah, makes sense.
Thank you.
Hi, sir. Good afternoon.
Good afternoon. Yes, Saurav. How are
Thank
you?
you, sir, for the beautiful knowledge you shared us.
My
Sir, I
pleasure,
have I have questions related to the operations and all.
Ji,
Suppose we basically before the customer has been occupied in the residential building and all, so we
Ji.
have to start the STP to take the occupational certificate and all. So so it is operational. So suppose 100 KLD STP is there. So you said that the for the MBBR it is constant load is there. Okay.
Ji,
So the initial days, so 3 to 5 months, or it is that day. So all the customer are not at.
No, the occupancy is low. Ji.
Yeah. So what the major pros and cons for that situation?
See how we need to manage an MBBR STP when there is lesser load as compared to a full load is you're feeding sewage into your aeration tank from your collection tank.
Correct.
There is a pump, right? This pump need to have a bypass. By default, any manufacturer, any STP vendor today is putting a bypass valve so that MBBR STP, we need to control the flow.
Okay.
If the same pump can give you a more flow when the tank level is high, less flow when the tank level drops to lower level, right? So they would always have one bypass valve to control the flow into the aeration tank. So if you, let us say in a 100 KL STP, today you are generating, your occupancy is only 20%, you are generating only 20 KL of water. You have to reduce your flow from the pump and make sure that the same water is distributed over 24 hours.
Sure. Okay.
Okay, sir. Control the flow in such a way that the flow never stops, or the
Correct.
tank is never overflowing. Neither the collection tank is never empty nor totally full.
Okay. So that controlling can be happened by automatically, or we have to do the manually?
Manual, sir. Here the
Manual,
operator
okay.
skill. Initially in the startup stage, operator skill is important. But
Correct.
to save energy, what you can do is you can periodically, you can have a timer on your air blower. You can run the blower in a on-off manner. Like every 1 hour, it will run for 30 minutes, 30 minutes it will switch off. Or in 1 hour, it can run for 20 minutes and switch off for 40 minutes.
Achha.
Okay, by doing this, initially you can regulate the cost. The excess aeration is also bad. Please understand this. Excess aeration or excess DO in aeration tank is as bad as low DO or not having aeration at all. So
Achha.
two challenges that our operator will have is, one is to control the flow, second is to control the DO. So need not have any kind of instrumentation, just go by thumb rule. What is the occupancy as a percentage? If the occupancy is 25%, then your blower should be running 25% of the time.
Correct, correct. And the sir, related to this only, see suppose we had given the position to the clients and all. So many clients will do the alteration in the apartments and all. So during the alteration, they they will do some types of civil works, the interior works, tiling works and all. That type of slurry, they will take इसमें pipes में छोड़ देते हैं. So this will comes in down and it will come in the STP, the collections tank and all. So that's once it is collected, so is any things to, can you please guide what to be done on this?
Sir, this problem we also faced in every apartment today. Whenever the client buys a flat, they are going to do a lot of polishing. Marble polishing will be there. Marble polishing, and the cleanup will generate a lot of what should I say, lime deposit going into the STP. We faced this problem, but I could not think of any proper solution. The only way was, we normally don't start the STP till 20-30% occupancy is there. Number one.
Correct, correct, okay.
Number two, if we have a properly designed oil and grease trap, these are heavier particles. These things can get trapped in the OGT itself. They will not carry forward to our collection tank.
Okay.
So from there, we need to physically scoop out and remove or call for a septic tanker with a vacuum pump. That pump can suck out these impurities. Or if this continues, probably we should ask the client to, after 3 months or so, get the collection tank emptied using a vacuum tanker, septic tanker.
Sure. Okay.
This is what we did in sites.
Okay. Yeah. Okay, sir. Thank you, sir. Thank you, sir, for the valuable knowledge.
My pleasure.
And,
sir.
can you please share us you said in the lecture, the separate videos has been prepared for the MBBR and SBR.
Yes, certainly, sir. They are already there on our YouTube channel. I'll ask my team to share links to you.
Sure, sure.
Sure, please arrange for
we'll share,
to be shared.
We'll share. Yeah.
From our website also, you can directly go to those pages.
Acha.
If you go to our website, each of these presentation will be properly named, date, topic, what we have covered. And if you just select there, from there, it will guide you to the YouTube, particular video on YouTube.
Sure.
In case of any difficulty, please let us know. We will correct that. Or we'll send you the right link.
Sure, sir.
Any more questions, please?
Hi, sir.
Hello, madam. How are you?
I'm fine. Sir, bioseptic tank and mana STP difference ఏంటి, sir? Most of the customers are asking bioseptic tank.
Okay. Basically, there is no difference between septic tank and bioseptic tank. See, in STP business, one of the major headache is each vendor putting his own name, right? What is the interest of a vendor? Let us say we are also vendors. What is our interest? I want to tell my customers that I do something different. So I give my process a different name. Nobody can talk about that name. See, every sewage treatment technology uses bacteria. It is biological in nature, right? And septic tank is septic tank. Like anybody does, Indus Ecowater does septic tank, or Mars does septic tank, or any ion exchange does septic tank, it is same. There cannot be any difference. But just for commercial reasons, we say bioseptic tank. Some people call it biodigester. Now the latest that you come across is biodigester. This biodigester is a name given by our Department of Atomic Energy and CSIR people, Council for Scientific Industrial Research. This biodigester is what is used in our railways now. Okay, they have developed a slightly different kind of culture, bacterial culture, which digests bacteria faster as compared to, which digests food as compared to conventional septic tank. Biodigester is faster compared to conventional septic tank. In conventional septic tank, you don't have to put any external bacteria. Whereas in a biodigester, you have to periodically keep adding this culture or bacteria species.
Yeah, one question I had.
Please.
I have a very typical question. There are so many ways of treating organic content, whether it is from sewage or from any other organic source. We are into a process of using advanced oxidation. So it includes processes like electrocoagulation, but it is more of forced oxidation rather than just coagulation.
Okay.
I'm just thinking about like completely a different type of it's a completely wild question. So please excuse me if you find it really wild out of the blue.
Yeah, no. I have seen wilder things.
Sewage has basically content which is suspended solids and organic.
Right.
That is what sewage is. And then there may be some contaminants that come from grey water, which can be some surfactants and all that. But it is still classified into suspended and organics.
Right.
So if I remove the suspended solids by chemical coagulation methods, simple chemical coagulation methods, and if you use a powerful oxidant like ozone to deal with the residual organic that is there, because some chemical coagulation will take away some organic content, which is part of the suspended solids and part of those contaminants which can be flocculated and separated out as a part of the sludge. But the remaining organics, and I'm assuming it is like 30% or 40% residual, if we use ozone treatment with certain contact time, is it possible that we can have reductions to the extent of what an MBBR can produce? Because there are a lot of, in this last IFAT exhibition, I visited yours, but before that I visited so many, because this is the only exhibition we got time to actually see others, because otherwise we were having our own stall. So this time I had spent good amount of time. There are so many people this year were exhibiting ozone or nanobubbles or whatever, just to increase the surface area or increase the potential of oxygen generation, hydroxide generation in the tank to expedite, increase DU or increase the, so do you see a possibility of using this as an alternative technique to solve sewage problems?
I have come across people who are using ozone, especially from Tamil Nadu and Pondicherry, where there are a lot of ozone generator manufacturers trying to offer this as an alternative technology. Right. Advanced oxidation techniques with hydroxyl radical are proven, well proven, beyond doubt, as technologies suitable for various industrial and domestic sewage. I know a company from Pune, if I remember the name, Whitewater Technologies. They use UV and hydrogen peroxide, ozone for this kind of treatment. Their focus was primarily on coolants, synthetic coolants, etc., treatment of coolants, etc. But the point is how effectively you can generate ozone, how effectively you can mix it. See, ozone has a very short half-life period. In a matter of seconds, 1 gram of ozone becomes half gram becomes 0.25 grams, like this. So because of this short lifespan, it has to be consumed at the point of generation. The moment you generate, you have to use it. You can't store ozone. Am I audible?
Yes, I'm hearing
Yeah,
you.
okay. So it's practically difficult for somebody to measure how much of ozone is generated, how much of it is. Again, you have two different methods of delivering ozone. You have that cascade shower type, and then you have Venturi injector, right? So both methods have its own advantage, disadvantage, but technically it is very much possible. I would say you should take a trial. And ozone generation is again an expensive process. You have to go for that corona discharge, or I don't know what all technologies have come now. But it should be possible. Any advanced oxidation methods.
Right. Thank you.
Sir,
Please go ahead.
సార్ కన్వెన్షనల్ మోడల్ అండ్ మన ఎఫ్ఆర్పి మోడల్లో మినిమం ఇన్పుట్ ఎంత ఉంటే ప్రాసెస్ జరుగుతుంది సార్?
See, when you are talking about our easy STP is primarily septic tank plus MBBR plus recirculation. What is the difference? The beauty of the Japanese technology is a lot of people don't understand. They just think it is septic tank plus MBBR. It is not septic tank plus MBBR. It is septic tank plus MBBR plus recirculation. We recirculate the water at least 5 times so that the given water is going through the septic tank, aerobic digestion, that is MBBR, again back to septic tank, that is anaerobic digestion, anaerobic, aerobic, anaerobic, aerobic. This happens multiple times, because of which the treated quality is extremely high. It is so nice, the settling part, the sewage is digested so much that suspended solids settle, and without using sand and carbon filter, you get suspended solids below 10 ppm in treated water. Your question of which is better, for small capacity, there is up to, personally I feel up to 50 KL, Jokasu or easy STP is the ideal choice. Because one, when the sewage generation is small, it is not only the capital cost. A person who has a 20 KL STP in their premises cannot afford to have a full-time operator 3 shifts a day. It is costly for them. It's practically not possible. If you use MBBR or MBR or any other process, you have to have an operator. If you go for Jokasu or if you go for easy STP, that problem is not there. We normally say up to 50 KL, operator is not required on a full-time basis. Just 1 hour to 2 hours every day is good enough. All right. Next week we'll plan it in Hindi.
Yeah.
Right?
Yes, sir.
Okay.
Yeah.
Thank everybody for their time. On Saturday weekend, you could have been doing so many things, but you choose to attend this webinar. Thank you so much for joining us. Look forward to seeing you in the next session. Thank you.